All right, so we're going to take a look now at another class of organic compounds, and this is the last class that we'll take a look at in this first chapter, or I'm sorry, chapter 11, and these are called aromatic compounds. Right, so when you hear the term aromatic, you may think, oh, maybe these smell kind of nice or pleasant. And way back when, that's kind of how they were named, or they were called that way, aromatic because of that. But since then, aromatic actually means something very different. We're not necessarily going to talk about the specifics of aromaticity. I think that might be saved, or might be better served in a advanced level organic class. What we're going to say here is that when we look at aromatic compounds in our class, we're going to be focusing really on a compound known as benzene and its derivatives. Okay, and what makes benzene aromatic is the fact that it's going to look like this. So we're going to see a ring structure with 6 carbons in it, and there's alternating double, single, double, single, double bonds, right? So we have alternating double single bonds throughout the entire structure. And those double single bonds are actually not locked in place, right? The electrons that make up those double bonds are actually free to move around. And sometimes you'll see benzene being drawn with the double bonds in different locations, right? So sometimes you'll see it drawn that way. Well, the truth is those lines don't actually represent where the double bonds are located. The electrons of the double bonds are actually free to move around the ring structure. And there's a third way by which benzene is represented, which is just a 6-sided hexagon with a circle in the middle. And that circle is meant to represent that those electrons are free to move around. They're called delocalized electrons. All right, so that's the structural formula for benzene. The chemical formula or the molecular formula, right? There are 6 carbons in it, and then there are also 6 H's in benzene, right? And if you look at the structure right down here, or that one, right, they all have 6 H's. This is, you can think of this here as the skeletal or the line angle structure where we don't show the H's. They're understood to be there. So benzene is sort of the prototypical aromatic compound, and really what makes it aromatic is this, that alternating double and single bonds around it, right? So it's not that it smells really nice, because it actually doesn't. And benzene is actually quite toxic. It is carcinogenic, and we don't typically use it in the lab unless you're in a very high level or advanced organic chemistry class. All right, so when we name compounds that have benzene in them, we use some common names. For derivatives of benzene. All right, so if you have a methyl group attached to benzene, you may think, oh, maybe that should be methylbenzene. Well, the name that we use is actually called toluene. And toluene is benzene with, like I said, the methyl group attached, which means then that that carbon here would be carbon number 1 by default, right? So if you name something as toluene, that carbon over here has to be carbon 1. We can have this NH2 group attached to benzene. This NH2 is called an amino group. When that's attached to benzene, we give it a special name. It's called aniline. And then when we have this OH, which is a hydroxyl group, when that's attached to benzene, we call it phenol as a special name. All right, so you have to know these 3 common derivatives of benzene. This one here is just the same thing. expressed in the line angle formula. So toluene with a CH3 attached, aniline with NH2 attached to it, and then phenol with the OH attached. And wherever those NH2 or OH is attached, those are going to be carbon number 1 by default. Right, we just draw it at the top, but you could just as easily draw it being attached to any of the carbons on that ring. All right, so when you have now additional things attached to the benzene ring, then we would need to say exactly where they're located. All right, so let's say we just had a chlorine attached to benzene, then we would call it chlorobenzene. There is no special name for that. We don't need the 1 in this case because the 1 is understood to be there, right? We want to give it the lowest number possible for where it's attached to the benzene ring, and it has to be carbon 1. When we have 2 or more substituents or groups, then we definitely need to make sure that we say where they're located. All right, so here I have 2 chlorines attached to benzene, so that would be dichlorobenzene, and I have to say exactly where they are located, right? So one is on carbon 1 and the other is on carbon 2, so it's 1,2-dichloro, and that's very different than 1,3-dichloro. All right, so when you number the ring, you want to give the lowest number possible to the substituents. So I would want to go clockwise in this case, 1, 2, 3, as opposed to going counterclockwise, 1, 2, 3, 4, 5, right? So 1,3-dichlorobenzene will always win versus 1,5-dichlorobenzene, right? You want to get the lowest number possible. And then similarly here, we have one on carbon 1 and one on carbon 4. So we'll say that's 1,4-dichlorobenzene, right? And that's something that we saw with numbering the ring structures with the cycloalkanes and the cycloalkenes as well. When we have derivatives of those benzene derivatives themselves, then what takes precedence in the numbering system is how we're going to name that benzene derivative. What do I mean by that? Well, if we have this structure here on the left side, right, what you need to be able to recognize is that you have benzene attached to that NH2, right? And this structure on its own, that's called aniline. And wherever that NH2 is attached, that has to be carbon 1 by default. So you're locked in place in terms of where carbon 1 has to be. So then we're just going to number it either clockwise or counterclockwise to give the lowest number to where that bromine is. And in this case, we want to go clockwise. So 1, 2, 3. The bromine is on carbon 3. So it's 3-bromo. And then aniline is our last name. Right, and that's the same case for this structure here in the middle. Right, you have to recognize that benzene attached to OH, right? This is phenol, which means that this here has to be carbon number 1 by default. If you name it as phenol, that has to be carbon 1. So in terms of numbering, in this case, you want to go counterclockwise to give a 2 and then a 4 to the positions of the substituents. Okay, so benzene and benzene derivatives and aromatic compounds are actually quite common. So for instance, you know, if you do a lot of baking or you make stuff in the kitchen and you use vanilla flavoring, right? The compound or the molecule that's responsible for the flavoring of vanilla is called vanillin. Right, and there's your aromatic, there's your benzene ring right here in the middle. Aspirin, right, take for a headache or a blood thinner, right? This is aromatic as well. There's your benzene right here in the middle. Acetaminophen, right, in the same sort of family of drugs, is aromatic as well. And then maybe something a little bit more exciting. This here is a compound known as TNT, and the common name for it is 2,4,6 trinitrotoluene, right? So there's the toluene, benzene with CH3 attached. This then has to be carbon number 1, right? And if you number, so that's 1, 2, 3, 4, 5, 6. So we have these nitro groups on carbons 2, 4, and 6. So that's where the 2,4,6 trinitrotoluene comes in. And the reason why it's called TNT is because it's just abbreviated. There's your T from tri, the N from nitro, and then the T from toluene, right? That gives you TNT, which is an explosive used to blow things up. So your aromatic compounds are, they are extremely common. This is just giving you 4 examples, but there are tons of examples of aromatic compounds. All right, let's take a look at a couple examples, right? So the first one here, we have our benzene, and then we have a chlorine attached to it. So that would be chlorobenzene. We don't need the 1 because the 1 is understood to be there, right? If you only have one thing on the ring, that has to be carbon 1. Here we have our benzene ring again, and we have 2 methyls, right? So it's going to be a dimethyl. All 3 are named as dimethyls. One of those has to be carbon 1, right? So if we start this with carbon 1, then we want to go clockwise, 1, 2, 3. So we have a carbon on 1, I'm sorry, a methyl on 1 and a methyl on 3. So it would be 1, 3 dimethyl benzene.